We have a MacBook Air A1466. It's 2017. It's liquid damaged, no power. We had previously taken out the board to do a pre-assessment to generate a quote, and now we want to do the actual repair. I'm just going to show you how the machine behaves. So it quarter fan spins when you connect power to the device. The device tries to start, but then the fan only spins a bit and then stops. I'm just going to show you guys how it behaves before we continue with the repair. Okay, so DC jack is connected. Just now connect charger to the device. Charger is connected. The fan tries to start and then stops. That's pretty much what it does. During our pre-assessment, we did spot sections on the board that are affected by liquid ingress. Basically, there are two sections of the board that we're having issues with. We have issues at U7600 and also issues by the SMC. Now, both cabs are sitting on a volt and are sitting on two separate voltage line. U7600. So the cab it's a C7601, and that it's a 1.5 volt line. It's a 1.5 volt line, and so because let's just quickly let's just confirm that as a C7601, which is a 1.5 line, and it's an SO rail, which explains why the device tries to start and then stops again. So what we want to confirm is we want to see if we have a short on that line, because the cap that we saw that's affected by liquid, it's not looking good. So the next thing we want to confirm is if we have a short on that line. Switch our multimeter to continuity mode, and then black probe on ground, and then red probe. We can measure for that at C7278, and yes, we have a short. Okay, we have a short. And most likely that short is generated by the cap that we saw, C7601. So what we want to do is we want to remove the cap from the circuitry and then see if our short will be resolved. Okay, the cap is out. The next thing we want to do is we want to see if our short is still there. And the short is gone. That's good. So now that that is resolved, we now move to the section of the SMC. So at the section of the SMC, we also see that we have a corroded cap at the section of the SMC, and that it's C5125. So the next thing we also want to do is we want to see if we have a short, if that cap is also creating a short. But by the way, these are two separate power rails. So we want to see if we have a short on that line, which is caused by C5125. And yes, we have a short. So the next thing we want to do is to also remove C5125 so as to address the short on that line. So we're hoping that by removing C5125, the short will be addressed. Otherwise, we may have to replace the SMC. So now let's remove C5125. Okay, let's check again to be sure if our short is still present. And we no longer have a short. That's good. So the next thing we want to do is to return to the section of U7600. Now let's return to the section of U7600, and let's hope that U7600 has not generated any type of damage to the PCH, and let's hope that U7600 itself has not suffered any form of damage. If hopefully that's the case, and then we can replace C7601. Okay, so what we want to do now is to replace 67601. But before we do that, we just prepare that section of the board. Get a donor board to get the components from. So just try to get another one that doesn't seem to have what we need. No, let's get another one. Okay, so this doesn't have what we need. Now we'll transfer in C7601. First to transfer that of the SMC, which is C5125. And then we transfer C76, and then we transfer that off E7600, which is C7601. Whenever you're doing these repairs, it's always good to make sure you add flux to your components so as to avoid any type of internal damage to your components. And it also allows a proper heat distributions. By the way, this is a 2017 board. It has the same features as a 2015. With almost all of the components can be used. 2015 components can be used on a 2017 board. Pretty much difference usually would be on the CPU configuration. Okay, let's clean the section we have worked. We always make sure to have a clean section. Whatever area we work, we always make sure we clean it up. We don't want to have flux laying around on the board. Okay, so there's a particular test pad that we just want to be sure, because the test pad seem to be affected, and that is P1 1.5 volt in SO, which is P good signal. So that track test point is connected to R8164. What we want to ensure is that there is a continuity between that pin and R8164. We can confirm that using our diode mode measurement. You can just first use another board to see what we're supposed to have there, and then confirm that on the board just to be sure that that signal is still healthy. So in diode mode, red probe to ground, 0.522. Okay, let's confirm. Let's just be sure that it's the same on the other board. Okay, yeah, that's pretty much good enough. Yes. Okay, so the line is healthy. Then we can move on. I'm just basically cleaning that section, and then also clean the section of the SMC. And then afterwards, we can now test to see if we have any changes. Just to confirm again, we don't have any short. Okay, that's good. Let's check that. No, that board had an issue on the PCH. We need another board for reference. Just grab another one. We need to confirm that we don't have any short left on the board before we connect power to it. Let's see. Diode mode, red probe on ground. Yeah, that's about what we're expecting to have. Just confirm that again one more time. Yeah, that's close enough. That's pretty much what we're expecting to get. Okay. The next thing we want to do is clean out also the section of the SMC. And then, by the way, we also have a cap that's looking funny by the section of the Thunderbolt, which is C3211. The cap that is not directly related to our issue, but that might pose an issue in future. It's a 3.3 volt line, so it's better to also make sure it's replaced. So that cap, we can have the cap. We can leave the section bare without having to replace the cap. The cap being on the circuitry may pose a problem to it when it shorts the line to ground. However, without the cap, the circuitry can still work 100%. But then we will be putting the cap back. So like I said, that section of the board is not directly related to the issue that we're having, which is the quarter fan spin. However, in future, should the cap fail, it may short the line to ground, and it's a 3.3 volt line. So just to be safe, it's better to address the issue now. So that it's U3210, and the cap is C3211. So on that line, you have on the line of the cap, you also have L3200. So let's just try to prepare that section of the board before we replace the cap. Okay, now we can transfer. Now we transfer it C3211. Okay, it's just a bit of a touch-up. The next thing we want to do is to clean that section where we worked. We always want to make sure that the board is well cleaned and there is no flux lying around the board. So after cleaning out the board, the next thing we want to do is to test. Now we can connect power to the board just to now confirm. As you know, we like to have the fan disconnected. We first want to connect power, use our multimeter to determine the state of the board before we connect the fan. So first and first, let's see what we have with the charger connected. Let's see what we have on our PPDC in. Switch our multimeter to voltage mode. PPDC in is 14.8, 40.7. That's 40.8, 40.7. That's about it. That's okay. Let's check out 3.4, 3.3. Yeah, PP3 V3 underscore G3 hotline. That's fine. What you're measuring? Yeah, okay. So the 5 volt at the inductor basically suggests that the machine is in SO state. So we usually use L7520 to confirm if the device is in SO state. Now we can connect our fan, and that's it. So the fan is starting. Unlike before, the fan would start and stop, but as we can see now, the fan is running without stopping. So the next thing we want to confirm is if at least we have an Apple logo. Hopefully the PCH has not been affected in any way. So the next thing we want to confirm is to see if we have an Apple logo. Afterwards, once we confirm that we have an Apple logo, the next thing that will happen is machine will then go into assembly stage and then tested and then finalized. Just quickly check if we have an Apple logo. Fan spin. Okay, let's check to see if we have Apple logo. There you go. That's an Apple logo. That's a beautiful Apple logo. Okay, it's a really good one. So the next thing that we'll be doing now is to basically assemble the device, and then basically we'll go through the necessary testings, and then the device will be finalized, and yeah, then we'll have a happy client. Pretty much that's about the repair. It's complete. Thank you guys. I'll see you in the next one. Thank you.